fairly simple to export your object from 3ds Max. All you have to do is make sure your file has only got geometry that you're going to print, because you can't select objects and export them separately. You can only export them all at once. So all you have to do is come up to the big green M or the 3ds Max symbol, select that. Within the export area, select export. Find the destination you want to export the object to. I'm going to name it and save it as an STL file. Now this won't work if you use the export selected option. So once that's exporting, just need to select the object's name. So in this case, we're going to name it ring. Select OK, and that's exported that out from 3ds Max. To export any of your objects from SolidWorks for the 3D printer, all you have to do is within your part file, come up to click the SolidWorks tab, select File, Save As, find where you want to save it, so in this case the desktop, name your part, and for the file type you need to select STL, and then you have your options button. What this does is it allows you to change the output, just keep it as binary, use millimeters as the unit, and you can play around with the resolution of the object. In this case we just want it to be fine. Actually no, let's set it to custom, give it a tolerance of maybe 0.033 sorry, and a 10-degree angle tolerance, and just make sure that the show STL info before file saving is turned to on, and if we select preview it also tells us exactly how many triangles this is going to produce and how big the file size is in bytes. So if I select OK and then save, it's going to give me the meshed model of the STL before it saves it, and then we can either select no or yes if we agree with what there is there. In this case I do, yep, and it's done. To export your geometry from Rhino to print, all you need to do is select your completed geometry, select File, Export Selected, select where you want to save it, type in a name, and it needs to be an STL. Now when we select Save, a export dialog will appear. Default will appear as this, the basic export options. When it's set to 0.01 millimeters, what that will do is it will create tiny little polygons on our surface, and that's not appropriate for our print. So if I select preview, you'll see we'll get a detail of fairly strong detail across the object, and that's going to make our file size a lot bigger, and the print job, it's going to take a lot longer to compute. If we set this to maybe a millimeter, we'll end up with polygons that are a lot bigger, but they're not going to show up as much in the model, and they're going to make it much easier for the computer to process. If you want to play around with more detailed controls, you can change different variables such as the maximum angle and aspect ratios of the polygons. If we set the maximum ratio to 1, let's say, it's going to make them all fairly square. So if we set them to 6, You see that change. But we're just going to go back to simple, hit preview, select OK. It needs to be binary, and turn off export open objects, which means when you import the objects into the printer, the ones that aren't closed won't appear, which means you have to go back and fix up the ones that aren't working. So we select OK, and that's done. To open our print in Catalyst EX, we need to go up to File, Open STL, and in this case we're going to select the torus. So the torus that has been imported is larger than the little bounding box in that on the left there. That's the bounding box that the printer can print, and it's done that because it's read the model in inches instead of millimeters. So all we have to do is select the yes button to convert that down. So if we click yes, that'll bring it down to the right size. Now to zoom, pan and rotate around the model, all you have to do is hold the Control, Alt and Shift buttons while you hold down the left mouse button while you move the mouse around, and that should allow you to move around the space to see what's going on. You'll see on the right here the properties. That'll tell us what the STL units is, so we need millimeters, and the scale and the amount of copies that we want to print, so that's all fine. And we see up in the orientation tab up on the top here, we'll be able to change the rotation and scale of our print. So what we can do on the right of the panel here, we can change the degrees and the scale that the print is going to be. So in this case, if we if we set the degrees to 90 and then rotate it on the Z axis, you'll notice that it's just rotating slightly. If we set it to 60, you can see it easier. You can see it rotating there. If we select Y, you'll see it rotating in the Y direction and X in the X direction. We can also look at the various different views from different sides just to make sure we're getting what we want. And as well, up here in the Orient Select Surface, if we select various different surfaces on our object to align with the top or bottom of the print, that will align that particular surface to the bottom. You probably want to use the bottom feature for this. It's much easier to work out where you want something to be flat. So now we need to send this off to the machine so we can work out how much this model will cost. Now to do this, we need to select Add to Pack, which is this button down here, and that will send the model off to the machine. So now the machine is calculating the horizontal slices through the object. This is where it's going to print. As well, it's calculating the supports. The supports are necessary so that if there's any element that's hanging in midair relative to your model, it's got something to actually solid to print on. The plastic that it prints is dissolvable, and you have to consider that whenever you're printing something with the machine, it needs to go through the acid bath at the end, and that takes time. As well, delicate models could possibly break in the turbulent acid in that bath because it is churning. But as we can see now, the lilac element that's appeared in our model, that's where it's building support. Soon, when we head back to reorient this torus, we can work out if we can possibly rotate it so that it's using up less support structure than what it needs to here. So that's going to happen after this is finished, and we can just wait for this, and it's almost done. If we now select the Pack tab, that'll take us to the dialog which shows us how much the print is going to cost, not only for main structure but also support material. So on the right, in the pack tab, we've got the pack details, which specifies the name of the object that we're printing, the volume of the model and the support material, and also the time variable for our print. Now, not only does reorienting our object make it cheaper, it could also make it faster to print. So to work out exactly how much the model will cost, you just need to use the Windows calculator, which on the laptop is there, and you need to add the model material and the support material together. So that's 16.47 plus 1.04, and you need to times that resulting number by $7. And we're left with $122.57. Now that's quite an expensive job for a Taurus, and now that we know how much this costs, we can make an assessment on if we want to print or if it needs to be reoriented to make it faster, possibly less support material, or we may need to remodel this to make it cheaper. So just to quickly reorient it, we can go back to the orientation tab, and to restore the original STL orientation, we just need to select the button on the right, Restore STL Orientation, and then that will take us back to the original Taurus. Now, I'm not going to play around with this. I reckon this is fairly reasonable, so I'm going to select Add to Pack, and it's going to recalculate. Another way of making this particular model cheaper is by giving it a hollow section through the solid area. Now, if you're dealing with walls or rods with your 3D print, you need to make sure that they've got an appropriate thickness, or otherwise they'll be too thin, and that appropriate thickness is more than 2 mil. If you're reorienting, then you'll need to save the original. That way you can have the two prints showing up on the same pack. It won't let you continue unless you do save the original. Now we're just going to skip ahead to when it enters the pack. So within the pack, we've now got our two prints. We've got the first one and the second one. To remove the first one, if we select number 1 and then go over to the right and select remove, it will delete it, and now we're left with our second orient. And now we've got a similar model material, a very similar support material, which is surprising, and a much quicker time. Now the original price was $122. If we clear that and then add those two volumes up, then times that by $7. 1.2 times 7. We're left with $125.16, which is about $3 more expensive. We're actually saving 3 hours print time. $3 for 3 hours is fairly decent deal in my book, but it does show you that the prices can change. Now that we know the price, we just need to take this exact value to Campus Central. Now when you go to Campus Central, you need to remember this particular code, PLU 82670. So PLU 82670. It's pasted on the computer for the 3D printing machine, and you'll also need to take your student ID. Make sure you've got that, or otherwise they won't accept the payment. And you'll need to receive the receipt and give that to either Gavin or David or anyone else working in the workshop at the time, so that they can start your print. If you don't do that, then nothing will happen. And have fun printing.